Hello, my name is Robin, and today we'll look at the topic of how to test AI using AI. First, a little bit of introduction. I'm Robin Gupta, co-founder and CEO at TestZeus. I have 3 plus years of leading product engineering by AI teams of up to 45 members. I'm a published author on the topic of software testing and automation, and I'm also an open source contributor to projects. Here are a few logos where I have worked in the past, and on the large QR code, you can find more details about us. First and foremost, let's look at the rise of the IA or intelligent applications. So, for example, large language models themselves, examples like OpenAI's GPT 4.5, DeepSeek R1, and other LLMs tend to behave in an intelligent fashion. The second bucket is about RAG applications, retrieval augmented generation, or even chatbots, which are wrappers on top of these models. And the third is agents. Agents like Tezus, Bold.new, or Harvey AI, which have agency inside them, or which can perform tasks autonomously using planning, memory, and tools. So these are just a few examples of intelligent applications which need to be tested in novel ways. That being said, let's look at these changing needs for software testing. As we can see on the table over here, I divided this into 3 columns. The first is criterion, second is the comparison between traditional software, and the third one, LLM based apps. The first example is behavior. For example, the traditional software behaves in a very predefined way based on the rules that it has. Think of it as a program having if, else, if. However, on the other hand, LLM based apps give the behavior of probability and prediction. The second criterion is output. For example, if you log in to an application like Salesforce, it will deterministically log you in, and there will always be that one output for that one input. But in the case of LLM based apps, these could provide non deterministic outputs. You can get different outcomes for the same question. Last but not the least, the testing strategy for traditional software was generally about the evaluations of it being right or wrong. On the other hand, for LLM based apps, they need to be evaluated on accuracy, quality, bias, consistency, and last but not the least, toxicity. That brings us to the automated evals. Now that we know what are evals, let's understand the what and when of automated evals. So, what should you evaluate? You must focus on context adherence, context relevance, correctness, bias, and toxicity in all intelligent applications. And when should you evaluate it? Now, that can be taken as cues from traditional software. For example, you can check after every change, bug fix, feature update, or data changes. You can have the pipeline steps and evaluations as part of pre-deployment in your SIT or UAT environment, wherein you check after merges to prod branch, end of sprint, or prior to shipping hotfixes. And last but not the least, it wouldn't hurt if we do a little bit of smoke testing post-deployment, for example, based on the demand from business or internal teams' needs. That brings us to today's demo application under test. What we will do is we'll build a small RAG-based application which will act as a quiz generator. We'll provide it with a sample data set around topics like physics and science, and then we'll ask the LLM to generate quiz questions for it, which can be provided to the user. So here is an example. Let's say if we ask it to write a quiz about science, it should respond back with some science questions for us with right and wrong answers. And for this application, we will use AI to perform the automated evals. So let's look at the pipeline. So from the starting point, we have the quiz generator app. We'll supplement it with a small quiz bank, and we'll also give it the user input and the prompt template. The prompt template defines what kind of outputs it should generate. The output of the quiz generator will go through the first ring of fire for rule-based evals, wherein we'll check if it generates answers which contain specific words or not. If yes, good. If no, fail the test case. The second gate is around formatting. Does it generate the quiz in the right format as specified or not? And then last but not the least, we'll look for things like hallucination, wherein we'll check it against negative prompts and see the kind of output that it generates. We'll also ask an AI-based automated eval system to reason about the answer and tell us whether the quiz generator app is working fine or not. That being said, it's time to roll up your sleeves and let's go on to some hands-on coding examples. So first and foremost, as you can see on my screen, we are using Google Colab. So these notebooks are IPython notebooks wherein you can write snippets of Python code and run them online. This is free and even you can use it for these experimental purposes. First and foremost, as we can see, we can run each of these cells individually. And in the second cell, we are highlighting my OpenAI API key being imported over here. You can use OpenAI or any other LLMs that you are comfortable with for the same IPython notebooks. These resources will be provided right after the session for your reference. So don't worry about that. First and foremost, we are highlighting the human template as the question. And as mentioned, the app that we are testing today is a quiz generator which uses the quiz bank or the dataset and large language models to generate quiz questions for, let's say, students. So here the quiz bank is being run and it has subjects around Da Vinci, Paris, telescopes, starry nights, and physics. Each of them have a category and a few facts. So ideally, when we ask this quiz generator app, it should use an LLM, look at the data set or this question bank, and generate a quiz for us. And that is how it performs retrieval augmented generation based on the data that we have provided it. Now what we'll do is we'll build a small prompt template. As part of this demonstration today, we'll be using LangChain as the core framework. And in the construct of LangChain, we have to highlight the prompt template. So the prompt template that we're following for the quiz generator app is very simple, nothing too complicated. We are asking the LLM to follow the below steps and generate a customized quiz for the user. It must identify the category which the user is asking, determine the subject, and then generate a quiz for the user based on the below format with a few questions and delimited. What we'll do is to build up is an open source library which acts as a wrapper on top of large language models. So we have provided the input as a human and the prompt template, and from there we'll move forward. So for example, if we just print the chat prompt, this is what goes through LangChain. So as we can see, this is the same quiz bank and the prompt template that we had highlighted earlier. Now we'll use GPT-4o with the temperature as 0 and choose that as the large language model for us today. As highlighted, you can use other large language models as well for the demonstration. Now from LangChain, we'll use the schema parser so that we get appropriate parsed outputs from the OpenAI's large language models. Now we'll take all of these components and we'll make them reusable as one piece. Okay. So nothing too complicated over here. We are creating an assistant chain with the system message, the human template, and the LLM with the prompt template that we have provided and the name of the model. So let's experiment with a quiz generator application. So we are asking it to generate a quiz about science and then we'll print the answer, what we are getting back from this. So what it has done is it has understood that the user is asking about the category science. And then based on the tags and labels that we have provided in the data set, it has generated quiz about telescopes and physics. All good so far. So now we'll create an eval for expected words as the first example. So what we are doing over here is we are creating a small quiz from the quiz generator application that we have created, and the output must be evaluated to contain certain expected words. So it is a very rule-based eval system. There is nothing magical, there is nothing AI inside it. We'll come to the AI once in the second example. So just keep up. Now what we are doing over here is that in the eval expected words, we have asked it to have a few expected words, and it's as simple as generating a quiz and then checking that the output should have the expected words. Okay. So when we run this with the eval, and then as expected, we should see that it creates a quiz about science. It picked up telescope and physics, generated a quiz, and then it had the right words inside it. However, let's create a negative test case or evals for refusal. So in that, what we are doing is that we are just asking our system to create a quiz and then invoking it on the question that we have asked it for. And if we ask it to generate a quiz about bread making, the decline response is, I'm sorry. So for example, if we run this, we'll start seeing the failures in that eval test. So we expected the assistant questions to include this, but it did not, is the idea. Very simple. You ask the quiz editor app to generate a quiz based on a topic. Look for specific words inside the answer. Nothing fancy, all simple Python over here. But a key problem with LLM based applications, as we saw earlier, is hallucinations. So now what we are doing is we are asking the quiz generator app to write a poem about conferences. Let's see what it does. So when we invoke the assistant application, it actually wrote a poem about conference. Now, a key failure point for this is that we had created a quiz generator app, not a poet. But when we asked it to create a poem about conferences, it broke all the rules about format and its system prompt and went ahead and wrote a small poem about conferences. Not cool. That is where we come to our second example, wherein we use an AI system to test that first AI system that we have built. So the first AI system which we had built was this quiz generator app, and we'll use another AI system with a system prompt to check out the responses from the first one. Very simple. So let's start running the same example from the top. As highlighted earlier, we are setting up the OpenAI API key. In the second block, we are also setting up the quiz bank. So nothing changed over here. It's the same quiz bank as from the previous ones, which has topics covered about telescopes, starry nights, physics, science, so on, so forth. Now what we are doing is that we are creating the assistant chain as our sample application under test. Basically, we are building the quiz generator app over here. So we are asking it to follow the steps to generate a customized quiz for the user. Just as we saw earlier, it should follow a certain format. Now, what we've also done is we have tried to harden the system prompt a little bit. We are asking it to only include questions from information in the quiz bank, only use explicit string matches for the category name, and if the user asks a question about a subject you do not have information about the quiz bank, just say that you do not know the answer. So we can also see that on the right hand side. It should say, I'm sorry, I do not have the information about that. Ask it to write a poem, it should not do that, is the idea. So we've run that small cell, it has done the setup for us. And then we'll build a prompt that tells the LLM to evaluate the output of the quizzes. Now this is the second evaluator AI system. So it has this very simple system prompt, which says you are an assistant that evaluates whether or not an assistant is producing valid quiz, and then it should give the answer. So the idea, as highlighted earlier, was that you have the quiz editor app, which is an LLM or an AI-based app, acts as a RAG application, retrieval augmented generation, takes the quiz bag, based on the system prompt provided, it should ID create the quizzes as the output. The second evaluator AI is, as we can see over here, has a system prompt acting as an assistant that evaluates the responses from the first one. So that is how we are using AI to test another AI system. Very simple. So moving forward, we simulate the LLM response to make a first small test, and we set the prompt for testing agent. As highlighted, you are evaluating a generated quiz based on the context that the assistant uses to create and an LLM response. Read the response carefully and determine if it looks like a quiz or not. Output Y if the response is a quiz, output N if the response does not look like a quiz. So that is where we are doing that assertion of the response from the first AI using the second AI as an evaluator. We use LangChain to build the prompt template for evaluation. We'll choose GPT and we'll import the parser to have a readable response. We'll connect all these pieces together in the variable chain, and we'll test the good LLM with positive response by invoking the eval chain. So basically, as we had highlighted, if the answers are correct, it should respond with a Y. If we don't get a proper quiz back, it will respond back with a no. So combining all these pieces, we'll create an eval chain using LangChain. And then what we'll also do is we'll check for a negative response. Now, the known bad result highlighted over here, or the negative test case, is that there are a lot of interesting facts. Tell me more about what you'd like to know. Now, this will not generate a quiz, and that is what the second AI should catch and fail the test case. So let's run that and see what's happening. So it also generated a small n. What we'll do is we'll compress the pieces of these systems into a test assistant so that we can run PyTest or test fixtures around it. So we are running the code for the test assistant, setting up for all these scenarios, and then there is a specific method which will look for a substring of the message, and it will also decline the response if it is not the correct response. So when we run that, we'll ask it on some facts which we had provided. And then if it is outside the knowledge base, as we can see, the LLM is also responding, I'm sorry, I do not have the information about that. We'll create the test release evals. And when we run that, as we can see, for the assertion, we've got an N where it should have got a Y because we have input the known bad result as we saw earlier. So that is how you can use the second AI system to check the first AI system. It's as simple as the second AI system has a prompt which checks that the quiz generator is generating the right outputs or not. Now, the same could be applicable for your customer support scenarios or outbound sales scenarios. For example, in the case of a customer support scenario, let's say your AI system is supposed to act as a customer service bot. It should ideally not reveal any secret information or should not go into hallucinations. So when you're building that bot or that AI application, you can have another AI evaluator with known bad results and then check for the behavior of that first customer support AI bot. That is how you can test AI systems using secondary AI systems. But let's not stop there. Let's make it more fun. What if not only could we find the deviations on the format, we could also find the deviations from the context adherence? And what if we could reason about the bad responses? So last but not the least, let's perform some automated evals with advanced examples. First and foremost, we have the OpenAI key being set up. The quiz bank is the same as earlier, and we'll create the assistant chain wherein it can act as a quiz generator for us using GPT-4o. What we'll do is we'll create the second AI system with a system prompt and give it a very specific direction, asking it to act as an assistant that evaluates how well the quiz assistant creates quizzes for a user by looking at the set of facts available to the assistant. So we are asking the second AI system to look at the same question bank given to the first one and see that the quiz generated by the first one adheres to that context or not. So we are asking it that your primary concern is making sure that only facts available are used. If you focus here on line number, only is actually written in bold. So what we found is that text written in bold in system prompt is acted upon strictly by large language models. So we'll highlight that, we'll run that small cell, and we'll also ask it to compare the content with the question bank. And if a fact is in the quiz but not in the question bank, then the quiz is bad. So we are specifically asking it to check for context relevance as part of the system prompt. So we are asking it to output Y if the quiz contains facts from the question bank and output N if it contains facts that are not in the question bank. So we'll create a function which will check for the evaluation and hallucinations. So in this case, when we run it, we'll find that while the class chat OpenAI is deprecated, when we ask it for a bad one, it says, I'm sorry, but books is not a part of the categories I can generate a quiz for. So as you can see in the question bank, we actually don't have anything around books. It has topics about telescope, science, starry night, physics, and Da Vinci. So that is how, in very simple words, it can check the context relevance. But let's improve the system prompt a little bit. So we are asking it to act as an assistant that evaluates how well the quiz assistant creates quizzes. Your primary concern is making sure that only facts available are used and helpful quizzes only contain facts in the test set. We'll rebuild the evaluator to not only provide the decision of the result, but also the explanation. So that is the fun part over here. So for example, we are not only asking it to compare the information in the quiz to the question bank, we are also giving it a few additional rules over here in line numbers 28 to 32. We are asking it to output an explanation of whether the quiz only references information in the context, make the explanation brief and only include a summary of a reasoning for the decision, include a clear yes or no, and then reference facts from the quiz bank if the answer is yes. And then in explanation, for example, if there could be a decision and then there could be a small explanation. So we'll rebuild that whole check prompt with the new prompt. And what we'll do is we'll also run it with a few small test data set. So for example, there are topics about science, about geography, and bread making or cooking. So ideally, it should pass the topics that we have in the quiz bank and it should fail the ones around bread making because we did not cover it. So what we'll do is we'll create this function data set and invoke the quiz generation. We'll use a library from Python called as pandas to help us display the results in a more readable format. Once we run this end-to-end piece, the data set and the evaluator AI, what we'll see is for the positive test cases, not only will it pass the test case or evaluation, for the negative ones, it will not just fail them. As highlighted in the system prompt for the evaluator AI, it will also try to look at the data set and then reason or explain its results to us. So, for example, in the first row, we are asking it to generate a quiz about science. And can you give me a quiz to test my knowledge? So, it generated that. So, the quiz generator app created a small quiz for the user. But then the evaluator AI checked the quiz based on the data set and highlighted that yes, the decision is right, the quiz is good, and gave an explanation of why it believes that the quiz was generated is accurate or not. Similarly, we asked it about geography, and last but not the least, when we asked it about bread making, not only did the quiz generator app replied, I'm sorry, I cannot give you a quiz on bread making, the evaluator AI also had the decision as no, and then explained that the quiz does not reference any facts from the question bank. And it has nothing to do with Da Vinci, Paris telescopes, so on. So, in very simple ways, what we have done is we created a small quiz generator app which takes a question bank, talks to the LLM, and generates quizzes. What we then did was part one looked for certain rule based evals that the generated quiz from this first AI based application contains a few words or not. Second, we checked for the format. And last but not the least, we created this evaluator AI, which not only checked for the context adherence and relevance based on the same data set provided to us for the quiz, it also gave us the explanation of why it passed or failed the test case. So that is how you can build AI systems to check other AI systems. Let's get back to our presentation. I'll put this in slideshow mode and time to unroll your. Okay, jokes aside, moving forward, let's zoom out a little bit and compress these concepts into a CI/CD pipeline, continuous integration, continuous testing pipeline for AI applications. Let's say you are doing some changes, you must do per commit evals in the dev feature branch. From there, merge to main. After that, you can do pre-release evals, like the second test around formatting that we did. Move it to deploy. And then last but not the least, after that, you can also check it for a few smoke scenarios with the evaluator AI that we had created and look at not just the pass-fail responses, but also the explanations. It is very important to highlight that not just the pre-release evals must also go through human review. Conferences when I highlighted that you can use AI systems to check the other AI systems, someone very smart in the audience asked me, then who checks both of these AI systems are working fine or not? The answer, as you can imagine, is today and forever humans. That being said, let's look at a few references. Infosys recently released a responsible AI toolkit, so I've highlighted which can help you do red teaming for your AI applications. Publishes their OpenAI evals, and then last but not the least, there's a very nice research paper on evaluation of large language models. That brings us to the closure of our session today. Feel free to show those questions, and you can also check out the world's first open source testing agent at the GitHub repo highlighted below. Thank you so much. Have a nice day or a nice evening. Stay curious, stay smart, take care, and bye-bye for now.